Hi friends, today we are discussing a topic of Zener diode. All we are seeing about a basic diode and one more PN junction diode, and the second diode is Zener diode. Remaining diodes also using in more applications, but mostly PN junction diode and Zener diode are frequently we are using regular electronic items. So what is a PN junction diode? PN junction diode we are discussing, it is a one type of switch, and it is a one-way switch having two biases. One is a forward bias and one is a reverse bias. And what is the characteristics of a PN junction diode? We know all those details. If you want those details, I will give link about the topic in my description. Please follow that link. And now we see the Zener diode. Main, what is the circuit symbol of Zener diode? PN junction diode, we know this is the PN junction diode, right? And in Zener diode, the symbol is little bit vary like this. This is the PN junction Zener diode symbol, circuit symbol of a Zener diode. In PN junction diode, same operation in Zener diode also, doping of electrons and holes, but here the characteristics are little bit vary. Means in this is the I and this is a V, and same in forward bias Zener diode also same like a PN junction diode, but in case of PN junction diode the reverse bias is not occurred. If occur in theoretically it is not, and in practical case it may occur but cause some constant in a PN junction diode. But in case of Zener diode, up to some voltage, after that we are reverse bias will occur. How it reverse bias is occurred and what is the properties of this reverse bias? So now here we see how it is the working of a characteristics of a Zener diode. Now we are taking same. This is in forward bias condition I and V. V forward, I forward. This is V reverse and I reverse. Same in case of a PN junction diode, reverse bias is occur, means power is dissipated, that time diode is destructive and gets damaged. So for that what we are doing in Zener diode, a little bit change, that is we are doping with more electrons and holes. So material we are doping mostly, that is the plus of Zener diode. Basically what is a Zener diode? A diode with adequate power dissipation capabilities to operate in a breakdown region. In breakdown region also where a diode will work, the diode is called as Zener diode. So this Zener diode is heavily doped compared to the ordinary diode. Ordinary diode means like a compared to PN diode. This is the heavily doped. So these are the VI characteristics. So we know this forward bias, and now we see about the reverse bias condition. Break down the junction. How it is the breakdown? This breakdown, how it will occur, we will see. This diode is we know the circuit symbol, anode and cathode. This diode is heavily doped. This diode is heavily doped and depletion layer will be thin. We know now that circuit diagram in I think you all are remember this. Holes, positive charge carriers and negative charge carriers, electrons. This is called depletion layer width, and this width have some voltage, external battery, we are giving some forward bias condition, reverse bias condition. You remember this? Okay, and same here. If diode is heavily doped, then depletion layer will be thin. Actually, in general PN junction diode, this reverse bias condition, this depletion region will be increased. That's why its reverse bias is not performed. But here heavily doped, then depletion layer will be thin. So breakdown occurs at a lower reverse voltage and breakdown voltage is sharp. So up to some condition it is same, and after that the current will flow like this. So this is breakdown voltage. This condition is a breakdown voltage or Zener diode voltage. But for this condition we have two breakdowns will occur. For sharpening the sharp increasing the current under breakdown conditions. So two conditions is occurred. One is the avalanche breakdown and second one is Zener and Zener breakdown. So now first we see what is the avalanche breakdown. So here in avalanche breakdown, both this avalanche breakdown and Zener breakdown, forward bias is the same. But this condition when will occur in case of reverse bias. So in reverse bias, avalanche breakdown, the depletion layer, and here what we are doping is this doping material is in avalanche breakdown condition, it is a thick. In that case, what will happen? Some these carriers, new carriers, what we are occur, those are collide with each other, and that's why this is cumulative in nature. So this avalanche of charge carriers are generated more. Avalanche means we know na flow. As more electrons will flow from this positive to negative side. So here depletion region will be less. In the condition, these are in a cumulative in nature. So this mechanism of carrier generation is known as avalanche multiplication. So flow of large amount of current is the same value of a reverse bias. We know, but this is a Zener breakdown. And avalanche breakdown, we will draw one more. This will occur to here. After this, here occur this. This is the avalanche breakdown region. So avalanche breakdown region, depletion layer will be thick and thin. This is the same condition, but the flow of electrons is more. Avalanche means a group of electrons will flow. That's why the mechanism of carrier generation is known as avalanche multiplication, and this process result a flow of large amount of current at the same value of reverse bias from here to same. Current is same up to here. This is the avalanche voltage, avalanche breakdown. Next one, what we see, that is the Zener breakdown. Zener breakdown, same as usual. This is forward bias. And Zener breakdown, up to some condition, same like avalanche, up to some condition, the new electron created a reverse current in a reverse bias diode and increase in current at a constant value of reverse bias voltage. Typically these heavily doped diodes are not going more than 6 volts. So compare it nearly here, and from here to current is constantly increasing. So voltage is not change. This region is breakdown of Zener diode. So this is the Zener voltage. This Zener voltage is maximum 6 volts. So from 6 volts onwards, the Zener voltage is constant and current will be varied. So these are main, the Zener diode is application is called as voltage regulators. In voltage regulators we are using these Zener diodes. And this in case of Zener diode also, the depletion layer will be very less. That means mostly 10 power 7 like this, very less. Zener breakdown occurs for lower breakdown voltage and avalanche breakdown occurs for higher breakdown voltage. This is the higher breakdown voltage and this is the lower breakdown voltage. So such diodes are normally called as a Zener diodes. This is about a Zener diode. Next we see the application of a Zener diode. Applications of a Zener diode. Mainly this Zener diode application is mostly used as a voltage regulator. This voltage regulator, we have one circuit diagram. So one resistor, Zener diode, other resistor. This is V in. Across the resistor we are taking output V0. This is our Zener diode. In Zener diode we have Zener breakdown and Zener voltage. This is R and this is RL. This is a circuit of a voltage regulator. Under reverse bias condition, voltage across diode remains almost constant. So current through diode is increased. We already know that in case of Zener diode regulator condition, we saw that. See here, in case of Zener reverse bias, voltage is constant, almost constant. The current through the diode increases. Maybe here A condition it is same, and in case of B, voltage is same, current is increasing. So the diode can be used as a voltage regulator. So provide constant voltage across the load resistance RL. Whereas input voltage is increased or decreased, it's not depend, means increasing voltage, input voltage may be vary. So Zener diode in reverse bias condition, input voltage does not fall below the Zener diode voltage. So the voltage across the diode will be constant, means Vi does not less than Zener voltage. In this condition, Zener voltage is constant, and Zener voltage is constant means the load voltage VL or V0 is constant. This is the basic application of a Zener diode, and this is the voltage regulator. This is the topic about Zener diode. If you understand this topic, please subscribe my channel and share to your friends. Thank you.